Alright, this video is probably almost a month after the last video segment that I recorded. I ran into a whole bunch of different problems. First off was the what is this, the lead screw. When it was in here, and these, it was way too wobbly. If I can get in there. But if you look at that, and just, oh, there goes their ramps board. But there's just a ton of play in there, and having one of these on the end supports was making the whole entire frame just wobbly. So I went through a whole redesign, and as compared to my original, these little tiny things for support, that's what I had at first. I've gone to these, which are super beefy. This thing is, hopefully it's going to work, but we'll see. I don't know yet. I've yet to power it up, but it seems to be okay. But instead of one rail on one corner and then another rail, so two rails on the corner, I have four total, and I actually have the entire assembly geared now. I went from the 8mm lead screw to a 1/2-inch rod, which is a lot beefier and should hopefully support it. I got one on each end here, got one on the other end there, so it's going to be off two corners the whole bed. And I've actually had the frame in there, and it's actually really sturdy with it in there. You can hardly move the frame itself, but I got it geared because it's a lot of weight on there. The aluminum plate that I had, the 6mm thick aluminum plate, is just too heavy. I ordered another one that's about half the thickness, and it's probably about 4 pounds, but I did some math and did some calculations on the thermal mass of it. That's the plate there. But the thermal mass for that would take about 800 watts to heat up to print ABS on, and that's just way too much power to use. So the half the thickness is about going to take about 400 watts, and I can actually pull that off. I actually got four of these to heat the bed. What I plan to do is, with the aluminum bed, put those underneath it, and then have those insulated with some insulation called aerogel. It's a really good insulator, and it'll keep all of the heat in, and that'll heat up the aluminum plate. And on top of the aluminum plate, I'm going to have a big glass plane on there that will heat up the or will get heated up with the aluminum plate. And the aluminum plate, once it's heated up and everything, the thermal mass should stay in there pretty well with the glass on top of it, because the insulation will actually keep a lot of the heat in, and the glass will actually keep the heat in. And this is the ramps board I have. When I was testing it out on the Z motors before, I fried my laptop because I did the old screwdriver and touched something there, and it fried the Arduino board. I have it. You can see it on there. The I don't know if it'll focus that close. Probably not. But anyway, the MOSFET here, the 5-volt control MOSFET, that's just fried. Everything else looks fine, but anyway, so I ordered a new Arduino as well. But my laptop, I don't know if I'm going to be able to fix that or not. It's something, sounds like a capacitor's like trying to pop or something when it's gone. I haven't really looked at it a whole lot yet, but I just had it apart once and got it working with just the battery. But as soon as I plug the power supply input in, something connects there where it just won't work. And here's the close-up of the little spacers that I printed out. These just kind of went on the rail here just to space everything out properly. Actually, it didn't go on that one. Actually, yeah, it was that one. But They're not fitting on there now, but everything does fit though. I don't know. And excuse me, the rail here I had to modify. I had to actually cut off some of the rod. This is just the 1/2 inch metal rod that I got from the hardware store. It's nothing fancy. And I just sanded it down. I might sand it down some more just to make it a little bit smoother, but it's pretty smooth. I mean, the bearings can handle it because it doesn't have to be like super hardened chrome smooth, because the bearings that I have on there are the 5mm. They're actually 14-inch diameter. They're pretty big bearings. They can handle it. And the actual lead screw in here is a little bit loose, which is actually not a bad thing because it gives it a little play, because it's not loose up and down wise, but side to side, and it has a little bit of play so it can move freely with the gears and everything in there. If I can zoom in on that at all. Oh, blurry, of course. But I had to grind down this bolt because it was hitting this edge. I designed it with like really small tolerances. So that's with that. And so I went from, this is the first one, then I added another bolt hole for the second one, and after that I decided to go bigger and went for that. And this one I didn't use because for some reason I was really tired when I designed it and the dimensions were off, the bearings didn't work, and so I printed out another one, went with this design because that's for the bearings, and this is one of the lead screw designs. I mean, this was really sturdy. This is great. This worked really awesome for what I needed it. And will this thing focus? No. Come on, focus. Okay, there we go. But that didn't quite work well, and I took out a chunk here because it was rubbing up against one of the edges there. The cat wants out. What do you want, cat? Make up your mind. And that's the main power supply. I'm actually going to be using two different power supplies. That's the main one that's going to run the motor, not for the axes, all of them, and the hot end. That's a 360 watt one. That's just for those. For the heat bed, I actually ordered a, was it 600 watt? Yeah, 600 watt power supply. It's an EVGA, something like that. But it's got one rail. I don't know if I'm going to switch that out with the one I have in my computer right now or not. I might switch them out. But the rail, single rail in that will work. The double rail one that I have in my computer right now would work as well, because I plan on powering these all in parallel, so two will be running off one rail, two will be running off the other rail. And I'm just running them 12 volt, and running them in parallel, it's going to drop the ohms down to, I measured it, it's like 0.6 ohms for all of them. I don't know if that's going to work with the power supply, if it's going to trip the power supply or not, and I'll find out. I don't know yet. It's experimental, because I tried with the 40 watt little heaters like this, like on the hot end here, and for the big plate it kind of heated it up a little bit, but not really. And I also got some Peltier chips. This is the 12706. I don't know if that's a focus or not. I can't see the camera. Focus. Anyway, so I got that. I tried that. That kind of worked a little bit, but being that I got these, what I'm actually thinking about doing is using one of these with a cooling heatsink, and for the fans on the heatsink up here, have the cold air blow through that, and for the hot end air I just have that blow off somewhere else. And I've never seen anything like that for it. Theoretically it would possibly work, just to cool it down really well, so I could just power that with 12 volts, because that's all that takes. And when you actually power these up with 12 volts, they get ice cold like a refrigerator, and actually a little, if there's any humidity in the air, it'll condense on there and it'll freeze, and you actually get a layer of ice on it. That's how cold they get. And for printing really hot plastics, you could get the hot end really hot and use something like that to thermally cool the heatsink end of it, and it would actually, it should theoretically help it to not get clogged or get stuck or anything like that. But I don't know, that's something I haven't tried yet. I might do that later on. I'm probably not going to do that to begin with, because I haven't even tested out these hot ends by themselves yet. But the next step I plan on doing, I'm probably not going to film it, but I got the, up here, see, I got the, zoom in, can't see it, but I got the belt tensors in here, the motor mounts to here, the other one's over here, or right here actually. So I'm going to mount the motor, put the belts and everything on these. I'm going to get the belts in and put the belts on the axes and get that all fired up. And then I'm going to also get the Z motors fired up. So I then wire everything and just do another test run. And there's the cat. Oh, and one of my thermistors in the hot ends is bad that came with it. So I'm glad I got extras. I just wanted to give an update on everything. That's kind of where I'm at right now. So I'm going to go ahead and get all this put together, and then I think I'll film the test when I get everything put all together and see if it works or not. We'll see. But that's it for now. Thanks for watching.